Okay, looking cool up here. So what's the probability of spinning a 12? Is 1 out of 16. There's only one 12 out of a total of 16. So what is that as a decimal? Okay, what's the probability of spinning a number that's more than 12? There's 4 of them that are more than 12 out of a total of 16, which is what? 1/4, 0.25. What's the probability of spinning a 4, 5, or a 9? Is 3 out of 16, which is what? 1875? Okay, then what's the probability of spinning a number less than 10? 9 out of 16, which is what? It's what?
5, 6, 2, 5.
Okay, so on the back of your one up there, we're gonna practice more of the same stuff that we did on Friday. So on Friday we talked about compound events, and then we talked about within compound events there's 2 different ways to do it. There's independent events and dependent events. So does anybody remember any differences between those? Okay, yep. That's right. What else? Does anybody remember anything different about them? Okay, so with independent events, this is with replacements. This is like if you're choosing cards, it's you take one card, you look at it, write it down, you put it back. Okay, replacement, you put it back. And then that way, the second time you take a card out, it's the same odds that it was before because you put it back like it was before. So then obviously, dependent is the opposite of that. It's without replacement. Okay, in independent event, the total stays the same because you're replacing it. You're putting whatever you took out, you put it back, so the total stays the same. With dependent, the total is changing. Okay, and with independent, earlier events don't affect later events. And then with dependent, the exact opposite of that, earlier events do affect later events. Okay, so let's go ahead and flip over or go over and go to this other page. So on 1 through 4 here, all we're doing is saying whether it's dependent or independent. So number 1 says one toss coin landing on heads and the next landing tails. Is that independent events or dependent events? Independent, because you flipping and getting a heads, does that affect what you get the next time when you flip the coin? No, they're totally independent. I mean, if it's like a standard coin, not rigged somehow or something, but if it's a standard coin, what you flip the first time is not going to affect what happens the next time. So those are independent events. Okay, number 2, rolling 2 6s in a row on a number cube. So you roll the die or whatever, you get a 6, you pick it up, you roll it again, get another 6. Were those two events, were they independent or dependent? Independent, okay. What you roll the first time does not affect what happens the second time. Number 3, drawing a red tile from a bag and then drawing a green tile after replacing the first tile.
Independent.
Okay, good. So you draw one out, you put it back. So what happens when you replace? Is that independent or dependent? It's independent because when you replace it, you put it back and you make it was like the first time. And so that first event didn't affect the second one. Okay, number 4, drawing a blue tile from a bag and then drawing a red tile without replacing the first one. Dependent. What's the key there? Okay, without replacing. All right, so we're going to work out a couple of these problems. So number 5 says, what's the probability of rolling a 2 and then spinning an A? So if we look at what's happening here, is you're rolling a number cube. I assume they mean just a standard die here. Then you're spinning a spinner with letters A through H on it. So we have compound events here because we're rolling the die and then we're spinning on this spinner. So first of all, what's the probability of rolling a 2? Is what? 1 out of 6. Because how many 2s are there on there? There's just 1. Now, what's the probability of spinning an A on this spinner? Okay, how many letters are there between A and H? A, B, C, D, E, F, G, H. There's 8. So the probability of spinning an A is 1/8. There's 1 A out of a total of 8. So remember, in compound events, we multiply the probability of each piece that's happening in there. Whether it's 2 events like this or if there's 10, you multiply them all together. So what's that going to be?
148.
It's going to be 1/48, and I do want this as a decimal. And what I want today in the decimal is I want three places after the decimal. So this is going to be 0. Is 0 point what? 0 to, is it a 1 or 0? Okay. All right, next one. What's the probability of rolling an even number and then spinning a vowel? All right, so how many even numbers are there? There's 3. 2, 4, and 6. So there's 3 out of 6 on a die. Okay, now what's the probability of spinning a vowel? How many vowels are there between A and H? How many vowels are there? Yeah, there's 2. Just A and E. Between A and H, there's only 2 vowels. So 2 out of 8 total, we already said. So that's going to give us 6 out of 48, which I can simplify that to what? One-eighth, which as a decimal is what? 0.125? Okay, let's drop down and look at this next group. All right, within this group, we're going to say if it's independent or dependent, which is really easy based off what they tell you. But we're going to say if independent, dependent, then there's 5 gray, 4 red, 5 white, 2 green, and 2 navy. So number 8 says, what's the probability of picking out a red and then picking one that's not green with replacement? So since it's with replacement, is that independent or dependent? It's independent. It's independent events. Okay, now first of all, let's just add them up real quick. How many total marbles are there?
18.
Okay, good. There's 5 gray, 4 red, 5 white, 2 green, 2 navy. So if you just add those up, 5, 4, 5, 2, and 2, there's 18 total. Okay, so what's the probability of picking out a red?
418.
Okay, it's 4 out of 18. Now we replace it, so we put it back in. So there's still going to be a total of 18 on the second time. The second time I'm looking for one that is just not green. So how many of them are not green? Yeah, there's 2 that are green, so that means the rest of them are not, so there's 16 of them. Okay, so this is going to give or not 6, it's going to give 64 over 324. What does 64 over 324 simplify to?
16 over 81.
16, whoops, golly, over 81. And then what is that as a decimal?
0.1975.
0.1975, so we'll round it, say 0.198. Is that right? I'm not looking at my calculator. Okay. Now, number 9 says probability of choosing a navy one and then a white one without replacement. So what does without replacement mean? It's dependent. Okay, so what's the probability of choosing out a navy? Is 2 out of 18. Now, this one we're not replacing it. So the marble that I draw out the first time I've kept. So how many total do we have in there for the second draw?
16.
There's 17. We just took one out. There's 2 navy, but I only took one of those out. Now, what's the probability of there being a white one after that?
5.
Is 5. So that's going to give 10 out of 306. What does 10 over 3 over 6 simplify to? 5 over what? And then what is that as a decimal?
0.032.
Okay, 0.033 actually. That 6 is going to round that up.